Good evening, minions. Welcome to the first session of Simple Harmonic Motion, and it's going to be a wonderful session. It's going to be a wonderful series, just like always. And we are going to see why things oscillate. We are going to see how to find the time period of oscillation, and I'm going to teach you all the important formulas, the basics, the theory, and we are going to do a lot of problems as well today. So get ready with me, Shreyas, your master teacher for physics at Vedantu, going live. And welcome, Science Priya Yalni, sorry, I think that's the name, if I'm correct. Okay, and Aarti, Tanmay, Kirito, Ridhima, Satish, Aishwarya. Hello everyone, welcome. So guys, if you are new, remember the only way we can know, yes, the only way we can know is if you type out in the chat box. So mark your attendance by posting comments and keep the chat box also active and your mind also active. Alright, so guys, this is Shreyas here, in case you do not know me, and I have been coaching students for their competitive examinations like JEE, KVPY, BITSAT, and you name it. And many of my students have been successful in clearing these examinations over the past several years. And many of my students have got 2-digit All India ranks in JEE Mains, JEE Advanced. Many of them have cleared KVPY exams, and many of them have even cleared their NEET examinations and are in the top-notch institutes in the country. So welcome everyone. All right. Hello Ranjite, hello Daily Mani, hello Jumna, hi Princey, hello everyone, hi Dinesh, hello everyone, hello. And you can also welcome all your batchmates. So guys, I really want you guys to bond really well, make friends also over here, and keep motivating others, keep supporting others, and if some spammer comes, you know what to do, guys. All right, so let's begin today's session. And guys, if you want to check out some really cool stuff, and by the way, I danced for you guys, I'm pretty sure that dance performance was really amazing. Just kidding. So you can check out my amazing dance performance on the Instagram channel Shreyas_Vedantu, and I hope you have already liked and commented on it as well. Hello everyone. Okay, so before I forget, all the new users out here, do not forget to hit the subscribe button. It's very simple, and if you are already maximized the screen, so guys, do not forget to briefly minimize it and hit the subscribe button. And also, if you are already subscribed, you know what to do. Go smash that like button out there, because unless you smash that like button, YouTube is not going to recommend our videos to you, and we are not going to get the energy to conduct these sessions. So go ahead, smash that like button. All right, now I hope you are back to the full screen mode, and also paying attention to the chats and other stuff, and also keep making notes, guys. That's very important. So this is the timetable for this week. So we started off with KVPI session. Today is SHM. We are going to continue with SHM, not just for this week, but even for next week. So remember, Thursday's class is at 2 o'clock, not at 7 o'clock. It's New Year's Eve. I'm going to spare you for that. And there is going to be a special session on Thursday at 5:50 p.m. and that's going to be the live streaming event by the Education Minister, who is going to declare the CBSE board dates for 2021. So very important session for all the 12th students. And Saturday we are going to have a marathon session, so come there prepared with all the food and the drinks, whatever you need for attending this long session. And guys, these are our mentee sessions, Tuesday and Sunday. There is no mentee quiz this time for physics, remember that. All right, Thursday already you have 2 sessions with me, so that's why there is no session on Thursday. Keep that in mind. So maths on Tuesday, that was today I think, and Sunday you are going to have it for chemistry. All right, so let's get going. Hi Sandesh, hello Aarti, hello Khushbu, hello Fida, welcome. So guys, I hope the Josh is really high, and let's begin today's session. And today there is lot of amazing stuff, so pay attention. So first of all, what is exactly periodic motion? So guys, what is periodic motion? So any motion which repeats itself again and again, and it should repeat in the exact same manner, then it is called as periodic motion. For example, if I lift my hand and I bring it down, okay, but next time I lift it really quick and bring it down, next time I bring it up and bring it down, this is not periodic motion if I'm doing it at different rates. I should do the exact same thing periodically, only then it is said to be a periodic motion. All right, so that's very important. Next, in periodic motion also there are more types, so we're going to come to that. Don't worry, everything will be clear and you're going to see a very, very important thing. So what is oscillation? Oscillation is basically to and fro motion. So I walk here and then I walk here and then I do some time pass and then I walk here and then I figure out, okay, I want to go there, so I go here. So that's oscillatory motion. It need not be periodic, please keep that in mind, because I might go there and come back and again go there and come back at different time intervals, so it may not necessarily be periodic, so keep that in mind. Okay, great. So guys, join in case you're joining in late, do not hesitate, join in, it's okay, we have just begun the session, and do not forget to hit the like button out there before you start watching the video. All right, now what exactly is simple harmonic motion? You will be like, okay, I thought simple harmonic was periodic and oscillatory. Yes, you're right, but there is a very specific thing that happens in simple harmonic motion. Now, to give you an idea of what exactly simple harmonic motion is, I have made a very beautiful diagram which nobody else gives you generally. So guys, I'll classify different kinds of motion and you will see what exactly SHM is, and that's what is there in our syllabus. Now, if you have a set which represents motion, like everybody must have drawn Venn diagrams during your school days, and you might have seen it in some memes and stuff like that. So if I draw a Venn diagram, this is a big set which represents motion of different systems. There can be a subset of just periodic motion. There can be a subset of projectile motion. There can be a subset of some other motion. So this is a subset called as periodic motion. And there can be another subset called as oscillatory motion. They are not the same thing. I'll give you an example. Imagine moon going around the earth is periodic, but it is not oscillatory, correct? Similarly, you swinging in the pendulum, all right, or sitting on a swing and going back and forth, that is periodic as well as oscillatory. Similarly, just oscillatory but not periodic will be me going from here to here, then wasting a lot of time, then coming here, then maybe going here quickly, then coming back here quickly. I'm not doing periodic motion, I'm just oscillating because my time to go here and there is not the same every time. That's the problem. All right, I hope this is clear. I hope this is clear. Yes, now if you understood, there are three different subcategories over here because this is the common set. Understand, there is an intersection over here. In that intersection, just because something repeats its motion, okay, just because something repeats its motion does not mean it is SHM. There is a smaller subset in that is simple harmonic motion. So a small subset is SHM, and that's what we are going to see. That's what should be there in your mind. Now I'm going to show you all of this using equations. I hope you guys are ready now to see a very, very interesting thing. Hello Pallavi ma'am, welcome, welcome. So I'm guessing Pallavi ma'am is also one teacher, or I don't know whether it's a student. All right, so let's get going to the graphs and some equations. So I'm going to show you the equations of SHM in a very, very simple way. Okay, so let me bring in the graphing calculator. Hello study buddy. All right, so guys, this is a very beautiful software, helps us plot graphs. It's called as Desmos. It's available for free. You can use it on the internet, or you can even download the app. Okay, so let's see how do we use this. Now here I'm going to write some equations and you're going to see the graphs very easily. For example, if I write y is equal to sine of x, you can see the graph very easily. Check it out. The graph is seen very easily, guys. Okay, just 1 second. You can see the graph very easily, and you can see that the graph goes up and down till +1 and -1. You can see it goes up till +1 and -1. All right. Now this is the graph of sine of x. Okay, this is the graph of sine of x. Now similarly, instead of sine of x, if I draw a graph of cos of x, this is how it looks like. Cos of 0 is 1, and cos graph starts from 1 and then it goes down and up. Now I'm going to play around with this. Come on guys, let's get ready. Let's get ready for this. Very interesting things are going to happen. This is sine of x. Now what if I make it 2 times of sine of x? If I make it 2 times of sine of x, the graph will go up up by +2 and it will come down by -2. You can see that. It will go up by +2 and it will come down by -2. Okay, that's what is going to happen. It's going to repeat itself. And do not forget, the graph completes one oscillation. One oscillation is completed here, and one oscillation will be basically, remember, 2 pi radians. And what is 2 pi? 2 times 3.14. 2 times 3.14 is 6.28. You can see that it is approximately 6.28 over here. You can see that 6.28 over here. Okay, so keep that in mind. Now, if instead of 2, if I make it, let's say for example, if I make it 3, it will elongate even further. If I make it something like 7, it will elongate even further in the y-axis. If I make it something like 0.7, then it will become very small. You can see that it has become small. So basically this number over here, what does it do? It changes the amplitude. So amplitude of that graph, amplitude is how much do you go on either side, up and down. That's the extent, maximum extent that you go is called as the amplitude. So the amplitude can be changed by changing this number. I hope this is clear. I hope this is clear. Everyone is enjoying this. I hope everybody is able to visualize this as well. Alrighty. Now I'm going to change another number over here. Instead of x, notice, instead of x, I'm going to put this number as 2x. So when I make this number as 2x, that means sine of 2x will be found faster. Understand? Because earlier I was putting x and I was finding sine x. Now when I make that x as 2x, the variations in 2x will be twice as fast as x. So these variations will happen really fast, and you can see that when I make it sine 2x, look at that. In fact, to compare, I can do one more thing. This was just sine x graph. So let me put y is equal to 3 sine 2x. Notice the blue graph is the sine 2x graph, the red one was sine x graph. The blue graph has gone up and down twice as compared to the red graph, twice. And if I make it sine 5x or 4x or something like that, just check this out. So instead of 2x, let me make this as 4x. Look at that, the blue graph will go up and down 1, 2, 3, 4. 4 times when the red graph has only gone once. You can see that. I hope you can see it. So what does this number do? So guys, what does this number 4 do? This number 4 changes how many times it goes up and down, how many times it goes up and down. Alright, and it can compress that graph or it can elongate that graph. Okay, so you can change that. If you want, I can make a parameter like t over here, and you can see what happens. This t can be varied. You can see when I change this parameter like t, okay, when I change this parameter, the graph compresses if I increase that value of t, and if I decrease that value which is there with x, it basically expands. Okay, so that's what happens. I hope this is clear. Okay. So now if this is clear, okay, so then oops, okay, I'll just make it as 2x or something. Now there is one more thing that I'm going to play around with. And that is, instead of just multiplying, let me add something and see what happens. Let me add, guys, and observe what happens. Let me add. So let me add x plus 0.1. Let me add x plus 0.1 or 0.2. You know what is going to happen? This graph is going to shift. But you know where it's going to shift? It's not going to shift ahead. It's going to shift behind. Why? Think about it. I'll tell you. X plus point, let's say 2. This graph has shifted behind. If you notice, look at that red graph. Red graph was passing through 0. The blue graph is passing through minus 0.2. If you don't believe me, check it out. Look at it. It has shifted by minus 0.2. You know why? Because when you put the value of x as negative 0.2, then the value of sine will be 0. Think about it. The value of sine will be 0 when you put the value of x as minus 0.2. And if instead of plus 0.2, if you put it as minus 0.2, guys, the graph will shift ahead. You can see that. You can clearly see that. So if I change this parameter, so let me just change this. So let me make it as plus t, guys. and see what happens. If I change this parameter, you can see the graph can be shifted right or left. So if I make this parameter positive, it will go towards left. If I make this parameter negative, it will move towards the right side. Is that clear, everyone? Are you guys visualizing this? Nobody will teach you like this, okay? I hope this is clear. Everyone? Everyone? Yes? This is what happens. Okay, okay. So now let me make it like 2x, and let me make this as, I don't know, 4 or something. It doesn't matter really. Now what if I add, okay, what if, guys, 1 second. Yeah, what if I add a number outside of this, something like, I don't know, 4 plus something, then the graph will shift up. Look at that, the graph went up. So the graph went up. So if I make this as 2, it will come down. Okay, 22 will make it really go up. If I make it just 0, then it will not shift at all. In fact, I can add a slider over here and show you what exactly happens. So when the value of t is 0, okay, it is on the x-axis. But when I increase that value over here, then the graph goes up, okay, and when I decrease that value, it goes down. Okay, so that's what happens, guys. So now we know what each of these terms do, So I'm going to give them some names. D, let me call this as A, let me call this as W, and let me call this as something like P. Okay, now let me add these variables. So now we know what each one does, what each one of these variables does. This D will shift this graph up or below. This graph will be shifted up or below, okay, this D. What does this A do? It increases the amplitude. It increases or changes the amplitude. It can decrease also, okay. So this D changes whether it goes up or down. This A changes the amplitude. What does this W, actually this is omega, what does this omega do? This compresses or expands that graph. It compresses or expands that graph. And what does this P, actually this is phi, you will see that this phi shifts that graph left or right. If it is positive, it will shift towards the left, and if it is negative, it will shift towards the right. Is that clear, everyone? Is that clear, everyone? Is everybody understanding this? Let me know in the chat box. And if you love this simulation, guys, do not forget to hit the like button out there. Come on, guys, show some support. Show some support. Okay, very good, very good, very good. Okay, very good, guys. So study buddy, you'll have to watch the replay, okay? Please watch the replay because I have a lot of stuff to cover, okay? So please watch the replay. Okay, okay. Great, great Priyagari, great Yalini, great Junna, great VK, great Ranjite. All right, Science Priyarthi. Amazing, amazing. So now, here is the thing, guys. Let's start writing the equations. See, oh, one thing I forgot to tell you. Okay, where did it go? Yes. So we had all these things, right? 1 second. Now, you can have something like plus 0.3 and something like that. Doesn't matter. 1 second. Now, what I wanted to tell you is, okay. Yeah, this is the equation for this graph, okay. What if I had some more terms? 2 sine 5x plus 3 sine 4x plus 0.4 sine I don't know, sine I don't know, like 2x is done? No, 2x is not done. 2x. Now you can see how that graph looks like. It's looking like one crazy thing out there, and I can change these parameters, something like this. I don't know whether you can see that. Okay, I hope you can see that. So maybe this is 5. You can see it's a periodic function. You can see it's a periodic function. You can see that. I can change these parameters, guys. It's up to me how I want to change it. These parameters will definitely affect everything. So I can make it like 0.6 or something like that, and you can see how these things change. So my point is, whenever you have multiple terms, what am I saying? Remember, write down all these things. Whenever you have multiple terms, that motion is periodic. That equation, you can see it is periodic in nature. It's repeating itself. Alright, so you can make this as, I don't know, if there's too much, let's make it x. You can see it's a periodic motion, clearly, because there are multiple terms. But this is not simple harmonic. This is not simple harmonic. Which is simple harmonic? When there is only one term. So whenever there are multiple terms, it's not simple harmonic. It's just periodic in nature. Probably looks like somebody's heartbeat out here. But when there is only one sign term, then it is simple harmonic. And very good, Albert. Don't spam Albert. Last warning, or else the admin will block. Okay, be careful. Okay. Yes, it looks like some DNA. Yes. All right. Now, yes, Akansha, you missed a lot of stuff, but don't worry. You can definitely watch the replay and you can catch up. Okay, don't worry. Or you can watch it in a delay mode. You can rewind back. Now, in SHM, okay. So the equation, guys. So what is the equation of SHM? It will be x is equal to a sine omega t plus phi. This is the equation of SHM. Everybody should remember this. Now what is each term in this? A is nothing but amplitude. What does amplitude do? I have already told you. In that graph, it is this one. That amplitude, it stretches or compresses that graph vertically. What is this? It compresses or expands the graph horizontally. So the stretching can happen like this way. So that is called as angular frequency. This is called as angular frequency. And this phi, what does this phi do? This phi basically shifts it here or there. So there is a shift like this or like this. I've told you that. This is called as phase constant or initial phase angle. It is called as initial phase angle or phase constant. Now, why these names have come, you will understand it only in the next class. Don't worry about it. For now, just understand this is true and let's just go ahead with it. Okay? Everyone comfortable till this point? This is the equation. So if this block is going back and forth and it is performing SHM, if you tell me time, I can tell you what is its position. This is the equation of its position as a function of time. You tell me the time, I'll tell you where it is. Now, how does each one of them affect the actual physical motion? Let's think about it. Guys, think about it. If amplitude is more, then what will happen? This block will go more here and there. It's going to go more here and there. If that A is small, it's not going to go so much. It's going to oscillate decently with a small amplitude. Is that correct? Everybody getting it? Next, what will this omega do? If omega is large, then this will go back and forth really fast. It's going to go back and forth really fast. If this omega is very small, then it's going to go slowly. It's going to go slowly. It's going to change the frequency. What will this phi do? Remember, this phi could shift the graph. This phi tells you where was it initially. That's all. It just gives you an idea of where it was initially. So just think about it. At t is equal to 0, if my x is already some value, that means when I started looking at it, that time where was this block? So it gives you an idea of the initial position of that block. If phi is 0, think about it. If phi is 0, then initially, that means when time is 0, think about it, sine will be also 0. That means x will also be 0. That means the particle started from the origin, guys. Yes. So it tells me more about the initial situation. So if the graph goes like this, oh, then I can understand already the particle was here, the block was here, and when I opened my eyes, the block was already in motion. It was already in motion somewhere here, in between. I hope this is clear. No problem, Uncharted. And if this is clear, let me also tell you some more terms over here, very, very important. Okay, so this position, which is the last position on the left and right, this is called as the extreme position. Now this is on the extreme left, and this position is again called as extreme position, but this is on the right side. This position is called as the mean position. What is this called? This is called as the mean position. So the distance from extreme to extreme is twice the amplitude. The distance from extreme to mean is just the amplitude. Now, can you guess what will be the velocity at the extreme position? What do you think will be the velocity at the extreme position? When it reaches the extreme position anywhere, what do you think will be the velocity at that instant? What do you think will be the velocity, guys? Come on, think and tell me. Quickly, 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 quickly. No, wrong. Extreme position. Think about it. You're going there, stop, turn back and go there. And stop and turn back. So what are you doing? You're turning back, guys. You're stopping over there. Remember? So it will be 0. So velocity will be 0 at these two places. So think about it. I run like this. I stop, turn back. And then again I go increase my speed. And then again stop and turn. So where do you think my speed will be maximum, guys? Come on, let me know in the chat box. Come on, let me know in the chat box. Where do you think my speed will be maximum? Where will it be? Yes, so where will the speed be maximum? Maximum at origin, correct, the mean position. So here the speed will be maximum. So this is max speed. Speed is maximum at the mean position. Very, very interesting. Excellent, excellent, guys, excellent. Keep that Josh up, keep that Josh up. Very good. Keep answering, very good, and keep helping each other. Excellent. Now, since we have talked about so many things, let's go ahead and talk about some more things. Okay, I'm going to clear off all these things, keep all these things in mind, and I hope you have been making notes about all this. Now, guys, okay, this was my position function. X is equal to a sine omega t plus phi. Now, some people ask, sir, is it necessary to use sine? No, you can also write it as a cos omega t plus phi. Okay, you can also use cos function. It's up to you. Either you use this or you use this. Up to you. Some books use this, some books use that, but you should be comfortable. The only thing is, remember, sine graphs always start from origin when phi is 0, but cosine graphs start from maximum value. So that's the small difference which you should keep in mind. Okay, great. Now, x is equal to a sine omega t plus phi. Keep paying close attention, guys. Lot of important stuff. Do not give up hope. Try to understand as much as possible. Don't lose hope. Okay, if I differentiate this, okay, so if I differentiate this, I will get velocity. So when I take the derivative, and that velocity, you can guess it, because this is something time plus phi, this omega will come out and it will become a omega. Sine's derivative is cos, so it will become cos omega t plus phi. So if you are familiar with the rules of derivatives, you will also realize why omega should come out. In case you do not know much about it, don't worry, you will learn it in 12th standard. For now, just understand whenever there is something variable plus something, that multiplying factor always comes outside. Okay, and sine's derivative is cosine. This is the velocity. Now, if you differentiate this again, what will you get? You will get acceleration, guys. And remember, again one omega will come outside, so it will become a omega square, and cos's derivative is minus sine, so I should put a minus, and there will be minus sine omega t plus phi. So from position, that's how you find velocity and acceleration. Very interesting stuff. So this was position, this was velocity, and this was acceleration. Isn't it? Everyone fine? Everyone fine? All righty. Hello Anamika, welcome. Join in. Keep up the Josh. Yes, Akansha. Yes. And many of you, I'm seeing after such a long time, guys, don't miss any classes. Guys, don't skip any classes. Keep your Josh high. Remember, the key to success is consistency. So consistently attend every class. Very good. Now, next thing up is, I think I can I have found position as a function of time, velocity as a function of time, acceleration as a function of time. I feel I can also write acceleration in terms of x. You will like, sir, how? Look at this. Acceleration, okay, is minus, okay, omega square in brackets a sine omega t plus phi. Correct? That's correct. Okay, I've just written few terms in bracket. What is there inside the square bracket is exactly the value of x. So acceleration will be minus omega square x, and that's the next formula which you should be blocking, guys. Alright, that's the next formula you should be blocking. Acceleration is negative omega square x. Very, very important. Excellent. I hope you have noted it down. Yes, 1D, 1F, WW, F3, F2. Yes, this is sufficient. Alright, Saurav. Yeah, a little bit late, but join in. Don't worry, you can also rewind back a little bit and catch up. Okay, try to catch up if you can. Now, one more thing that I want to tell you. Okay, let me just erase all of this. I can do one more magical thing. X is a sine omega t plus phi. Velocity was a omega cos omega t plus phi. Now I'll do a magical thing and you'll see what I'm going to do. What will be sine of omega t plus phi? It will be nothing but x by a. And what will be cos of omega t plus phi? It will be nothing but v by a omega. Now what is sine square of something plus cos square of that same thing? Isn't it 1? Isn't sine square plus cos square 1? So why can't I just square these two and do some magical stuff? So it will become x square by a square plus v square by a square omega square is equal to 1. And if you're already in 12th standard, you know this is the equation of ellipse. But anyways, most of you might be in 11th, so let me not talk much about it. So just rearrange these terms, rearrange this and see what you get. So you can write it as x square omega square plus v square is equal to, I have taken LCM, bring that a square omega square on the top and just shift the terms, guys. It's not that difficult. So v square will be omega square into a square minus x square. Therefore, v will be omega root of a square minus x square, and that is our next result. That is our next formula which you should remember. Very, very important formula. Velocity is a function of x. Yes, velocity is a function of x. Next formula that I have given to you. Remember all these stuff, guys. Very, very important. Very, very important. Okay, great. Now, next thing that I want to tell you, is, remember I had told you about omega. Omega is also related to the time period of oscillation, and omega is 2 pi by t. So what is this t? What is this t? This t is nothing but time period of oscillation. And do not forget, 1 by t is nothing but frequency, so I can write it as 2 pi f as well, and this f is nothing but just your frequency, but this frequency is just in hertz. Please keep that in mind. Time period is in seconds, and do not forget omega, which is angular frequency, is always radians per second. Keep that in mind. Okay, so this is another formula which you should keep in mind. Very similar to circular motion. Yes, remember circular motion, same formulas, no difference at all. So radians per second. All right. So look at this simulation. Very simply, it tells you how the block or that mass oscillates back and forth and how the position changes with time. Very important graph. This is nothing but like a sine or a cosine graph which goes up and down. So as the block goes up and down, you can see at the topmost point the velocity momentarily becomes 0 and it becomes maximum when it passes here, and it stops, becomes maximum, stops. So at the extremes velocity is 0, at mean the velocity is maximum, and the extent till which it goes up and down is the amplitude and stuff like that. So this is the equilibrium or the mean position. A lot of important things that you can see. Very, very interesting. So let's start solving a question, guys. Let's start solving a question. Oops, okay. 1 second. Yeah. Now, what I'm going to do is I'm going to take some values and I'm going to solve those. 1 second. I'm very good, Brajesh. Join in. Follow me. You're a little bit late, but it's okay. Join in. I've started with some basic problems now. Okay, so pay attention. So let's take some values and solve this. Okay, now imagine, guys. Imagine some equation is given to you. Something like x is equal to maybe 5 sine. Okay, 5 sine. All right. 2 pi t plus pi by 6. This is what is given to you. And now I ask you, find max, all right, max speed, max acceleration, find then the time period, frequency, also find initial position, also find initial velocity, also find initial acceleration. So many things I want to find. So let's see how do we find all these things. Let's begin. Get ready, guys. Now, since I know position, I can find everything about it. How? Just differentiate and we know how to get velocity. Remember, velocity is a omega. So 5 into 2 pi will become 10 pi, correct? A into omega, cos instead of sine, you will have cos, and you will have 2 pi t plus pi by 6. That's the velocity. Similarly, you can find acceleration, and acceleration will be this into again that omega. So 10 pi into 2 pi will become 20 pi square. Cos's derivative is negative sine. Remember, 2 pi t plus pi by 6. Great. Now let's try to figure out everything now. What is the maximum speed? So guys, think about it. When I want to find maximum speed, look at this equation. What is the maximum value of cos? 1, right? Doesn't matter what is there inside it. There could be donkeys, there could be monkeys inside it. Doesn't really matter. The maximum value of cos is 1. Least value is -1. So magnitude wise, the maximum value is 1. So whatever gets multiplied by it should be the maximum value of speed. So can I say very clearly, max speed is nothing but 10 pi but meters per second? Correct? Isn't it? A omega. So this 10 pi was nothing but amplitude into omega was the maximum speed, isn't it? Now maximum acceleration, but let's say I'm just asking the magnitude of the acceleration. So what will be the maximum acceleration? So max acceleration magnitude. Look at this equation. Again, you have a sine term. There can be donkeys, monkeys inside it, but the maximum value of sine is 1. So what is getting multiplied by sine? 20 pi square. Ignore that minus sign. I'm asking the magnitude. So max value will be 20 pi square meters per second square. Is that correct, everyone? Yes, very good. Yali, Ashwarya, Princey, very good. You guys are answering really quick. Very good. Next, what is the time period and frequency? Okay, for that check what is omega. Now omega here is 2 pi radians per second, isn't it? It's given. This is omega. So guys, what will be time period? 2 pi by omega, and just put it over here. So what will it become? It will become 1. So 1 second is the answer for time period. So it takes 1 second to complete an oscillation, and frequency, remember, is 1 by time period. So it will be 1 hertz. So I have found that out as well. Next is initial position, velocity and acceleration. Now the meaning of the word initial is just put the value of time as 0 and see what is the value that you get. What is the value of x that you get? Put the value of time as 0. So what will you get? Sine of 0 plus pi by 6. So you'll get it as 5 sine pi by 6. What is sine of pi by 6? Pi by 6 is 30 degrees. Sine 30 is half. So it will become 5 by 2 meters. Similarly, what will be the velocity initially? Velocity initially will be, use this equation. put the value of time as 0. Cos of pi by 6. So that will become 10 pi cos pi by 6. What is cos 30? Root 3 by 2. So it will become 5 root 3 pi meters per second. I hope this is clear. And last value, initial acceleration. Initial acceleration, so use this equation. So A naught will be minus 20 pi square. Put the value of time as 0. So again, sine of pi by 6. Sine of 30 is half. So it will become minus 10 pi square meters per second square. Are you getting the hang of solving these equations? From one equation, see what and all we have found out. See what and all we have found out. So many things we have found out from this. Isn't it interesting? Yes, you can also approximate pi square as 10, approximate value. So it will become minus 100 meters per second square. Now, if one had to visualize how it looks like, then I will show it to you. Don't worry, I'll show it to you. If this is x equals to 0, what is the amplitude? Amplitude is 5. So x equals to 5 is here and x equals to minus 5 is here. So you know where that particle is? You know where that particle is? Initially, it is at 2.5 meters. Oh, 2.5 meters means it will be somewhere here. So that block is somewhere over here initially. So it is at x is equal to 2.5 meters. Where is it going? Oh, the velocity value is positive, 5 root 3 pi. That's the velocity. So positive means towards the right side. So initially it is going there. But acceleration is negative. So velocity is here, but acceleration is here. What does this tell you? What does this tell you? What does this tell you? This tells you, guys, understand, this tells you that it is decelerating. Akansha, where did I not cancel 2 pi? Okay, so if you can tell me, but I think everywhere else it's fine. Okay, so understood, guys, acceleration is opposite to velocity, that means it is deceleration. All right, great. So shall we do some more problems now? Let's change the scenario. Let's change the scenario. Okay, let's change the scenario a little bit and see what happens. So now what I'm going to do, okay, I don't need all this. Okay, so now what if I frame few more questions? Find average speed, find average velocity, also find acceleration when displacement is 1 meter. Okay, so many questions. Then also find velocity when displacement is 1 meter. These are the next set of questions. Let's see what do we do now. Let's see what do we do. Okay, so I don't need these equations, I guess. I will erase this same question, but I'm asking, or same scenario, but I'm asking a different set of things over here. First thing, what is the average speed? Now think about it. In one complete oscillation, to find the speed, what I need to do is find the total distance and divide it by the time. What is the total distance it travels in one oscillation, guys? What is the total? Yes, Paulami, I do teach on paid platforms. Yes, I teach on YouTube, regular sessions, micro courses everywhere. So what is that total distance it travels in one time period? 5 meters here, 5 meters there, 5 meters there, and 5 meters here. So in one oscillation, how much is it traveling? I think it is traveling 5 plus 5 plus 5 plus 5. Remember, amplitude, 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 amplitude. So basically 5 multiplied by 4. I hope this is clear. Guys, remember this value over here is x is equal to 5. Okay. Now how much time does it take? We just figured out what is the time period. Time period was 1 second. In previously we just figured it out. So what is the average speed? It is 20 meters per second. That's the answer. Correct. Now, next set. Imagine I ask you to find average velocity. Now, average velocity is displacement upon the time. What is the displacement in one complete oscillation? What is the displacement? Displacement is 0. The time could be anything, doesn't matter, but the answer will be 0. So average velocity of SHM is always 0, but average speed is not 0. Very interesting. Next set of questions, let's do this. Come on guys, get ready. So next set is, what is the acceleration when displacement is 1 meter? So what will you do? You will use this equation. A is minus omega square x. Remember this? So what is omega? Omega is 2 pi. So you will use 2 pi whole square. And what is x? X is 1. So it will become minus 4 pi square meters per second square. So easy to calculate if you remember the formulas. Then the next set of question. Velocity when the displacement is 1 meter. So for that I'll use omega root a square minus x square, this equation. So omega is 2 pi, root of amplitude. How much is the amplitude? It is 5. So 5 square minus x is 1 because that's what has been asked. Okay, so it will become 2 pi, 5 square 25, 25 minus 1, 24. So this will become 2 pi root 25 minus 1, which is root 24. You can further simplify it, but that's the answer. I hope this is clear how to solve the questions. Just one equation will give you so many things. So many things it will give you guys. So many things. Yes, Bhavna, I have taught. You can watch that video of properties of solids in the playlist. It will be there in the past session. Great. All right. Okay. So we'll exit the notes. All right. So there is a lot of stuff I'm going to teach you today. So guys, get ready. Be prepared now. A lot of stuff is coming. Now, when you have a spring mass system, okay, look at this, how beautiful it is going. It stops, passes by with maximum speed, stops, passes by with maximum speed, and goes back and forth. This line, this black line is equilibrium position. Can I say, is this the mean position or extreme position? This black line, guys. What do you think? Is this black line mean position or is this extreme position? Is this mean or extreme? Come on. Yes, it is the mean position. Now this red arrow mark is the force, restoring force by the spring. Yes, it's the restoring force by the spring. So remember, the force by the spring is always minus kx, where if this is x and if this is force, if x is positive, force is always negative, assuming x is there positive. So by sign convention, if right side is positive, the force will be negative. Obviously, makes sense. Now, think about it. What is force? Force is mass into acceleration. So it is minus kx, correct? Correct? Force is mass into acceleration. Okay, now if it is performing a SHM, don't I know the value of acceleration? Because it is oscillating back and forth, and if it is performing SHM, so then the acceleration will be minus omega square x. This is because it is a SHM, and this will be minus kx, obviously then. Now what will happen? Xx goes, minus minus goes, so you'll have m omega square is equal to k. Now what will happen? Omega will become root of k by m. We have got the answer, whatever we needed. Angular frequency of a simple spring mass system is root k by m, guys. So fast I am doing it for you. And remember the formula for time period? What was time period? It was 2 pi by omega. So guys, what will be the time period? 2 pi by omega. Flip it. So it will become 2 pi under root m by k. That's the formula. So if you have a spring mass system, you can quickly find how much time it will take to oscillate. It will take 2 pi root m by k. Think about it. If mass is very huge, it will take a long time to pull it and stop it, again pull it and throw it there. Inertia is more, so it will oscillate slowly. But if K is very large, spring stiffness is very large, it will pull it very quickly and again pull it very quickly. So it's going to happen really quickly. So time period will be very small. Understand that. So that's the formula. Okay, time period is 2 pi under root m by k. You can find every bit of it using this. So look at this very beautiful thing out here. You can see it, equilibrium position. Blue line is the x value, the red line is the force. You can see that. Very beautiful simulation, guys, for all of you. Very beautiful simulation for all of you. Excellent, guys. And if you're loving all these explanations, you know what to do, guys. Go hit the like button and call your friends, guys. I'm not really happy with you. You guys are not calling all your friends from school and coaching and all that. Come on, call. You will have fun when you all have your friends along with you over here in all these sessions. Come on, do that. Okay. Now, let's do this question. K value is pi, M value is 4, mean position is the origin, alright. At time 0, mass is at rest at 0.5 meters on the x line. Okay, so let me draw this first. What is given? I have the x-axis and this is our y-axis. Okay, this is x-axis, this is obviously the origin. According to this, the mean position is at the origin. Okay, so I'll just say this is the mean position, and at t is equal to 0, mass is at 0.5 meters. That means over here, let's say x is 0.5 meters, and it is at rest. Very, very important. So guys, can you quickly tell me what is this point exactly in SHM terms? What is this point exactly in SHM terms? Is this some special point? X is equal to 0.5 and it is at rest. Is it something? Is it something? Don't worry, you can make friends here at least. Extreme, very good, excellent, guys. So this is, therefore, implies this is extreme position. Very good, guys. Now I'll tell you what is the intention of this question. I want to find the entire Khandan. Find the entire Khandan means find everything about it. Put a CID, put a detective, find everything. Find everything. I will call it as Khandan. Find everything about that. Let's try to find everything about it. It's not that difficult. Okay, so can you quickly tell me what should be the amplitude of the motion? What should be the amplitude value? Quickly. What is the amplitude value? Quickly. What is the amplitude? Yes, what is the amplitude? This is mean, this is extreme. Very easy, very easy. Yes, half. It is 0.5 meters. Excellent. Next, mass is given, K is given. What can I find? I can find omega. Omega is root K by M. Remember, I just told you. What is K? It is pi. And what is M? Okay, I think it was supposed to be pi square so that we can make things simple. Okay, it was supposed to be pi square, guys. I think that square did not come out. So this was pi square to make things a little bit simple for us by M. So M is nothing but 4. So this will become pi by 2 radians per second. Similarly, I can also find the time period. Time period is 2 pi by omega. So think about it. If I divide it by omega, what will happen? It will make it 4 seconds. Isn't it? Time period is 4 seconds. Frequency 1 by 4, which is 0.25 hertz. I found out so much of information just by this one line already. Now I'll find more. If I ask you what is the value of phi? What is the value of phi? Can we find that out? Yes, I'll tell you how. Okay, x is a sine omega t plus phi. Guys, think about it. At t is equal to 0, what is the value of x? Value of x is 0.5. What is the value of amplitude? Oh, that's also 0.5. What is the value of omega? Okay, that is pi by 2. But that was unnecessary because I'm going to put the value of time as 0 plus phi. I don't know that. I want to find that out. 0.5 goes 1 is equal to sine of phi. Correct? When is sine's value 1, guys? Obviously, when it is pi by 2. When it is pi by 2. Now, can I frame the equation? The original SHM equation? Yes. So, x is 0.5 sine pi by 2 t plus pi by 2. That's it. I found this equation. And didn't we solve a problem on this before? Similarly, A very similar problem. Once you know this, you can find so many other things, velocity, acceleration, this, that, everything you can find. So guys, this is how that equation comes if you know the mass and the spring constant. And remember one thing, if initially the mass was somewhere else, won't this value also change? Won't this value change? So that is what I told you. Phi depends on where was it initially. Understand that. Understand that. Very important stuff. Okay. Great, Aishwarya, Aarti, Akansha, Krito. Very good, Alekya. Very good, VK. Very good, everyone. Excellent. Okay, by the way, now there are more problems, some amazing problems where many people are going to make mistakes. But before that, guys, if you want to study under me, especially all the 11th standard kids, if you are wondering, is sir going to teach in 12th standard? Obviously. But on YouTube or on paid platforms, guys, I'm going to teach on the paid platforms as well as YouTube. Remember that. Even Wazim sir will be there, even Shimon sir will be there. So, guys, do not hesitate to join now, because remember one thing, that the faster you start, the sooner you start, then you have a bigger advantage, you have a head start, where you will get a lot of micro courses. You will also have the option to learn in English and Hindi, but I'm pretty sure most of you are going to prefer English. And you have a lot of teachers, obviously, and you're going to have lots of tests, assignments and report cards, and lot of test analysis and test discussions which are going to be done. And you will have your regular batches plus special batches for boards, KVPY, Olympiads, you name it. And all this is going to be at a very affordable price. Please check all the details for the pro subscription for 12th, 11th droppers. So like for the 12th standard students, for the remaining few months, if you want to enroll yourself for 3 months, the price after discount comes down from 21,000 to directly 16,800. For the 11th standard students, for the next 3 months, it comes down from 13,500 to just 10,800 after 20% off. And for the droppers, for 3 months, it comes from 25,500 to directly 20,400. So that's the advantage that you get if you use these coupon codes. More than the coupon codes, guys, I really want you to enroll yourself, try out all this stuff. I'm pretty sure you're going to like it. If you are having some doubt, don't worry, try it out for at least 1 month. And if you don't like, no problem, don't subscribe again, right? But I'm pretty sure you're going to come back. So at least try it out for 1 month. Use this coupon code SHHPRO for getting the pro subscriptions. Okay? Yes. I am so glad, guys, when you say such things, Akansha and VK and others, like when you say that you are the mascot, guys, it really it freshens me up. It gives me a lot of energy, because what do I expect from you? There are only few things that I expect from you. One is like you attend my classes. 2 is like you show me some love and support. 3 is obviously you have to do well in your exams, and I'm going to be there behind you. That's all I expect. Thank you, VK. I know I keep seeing all your comments and everything on Instagram. Thank you, Princey. Thank you everyone for all the support. Sandmaster 2022 dropper batch, not so fast, my dear friend. Understand, Sandmaster, you're too early for the dropper batch for 2022. You have time, so get yourself enrolled in the normal batch, and the 11th standard revision also will be done in the micro courses. So don't join a dropper batch for 2022. Okay? Yes, definitely you will get all the support and help that you can get from me, whatever is possible. Yes, thank you, guys. Okay, so guys, I was just thinking, should I tell you one surprise? Well, a lot of people are going to be there in something like a Google Meet, which is going to be conducted at 11 o'clock on 31st December, just for 5 minutes. So if you want to join in that Google Meet, where many of the teachers will be there, and probably I might be also going live. I don't know whether it will be Google Meet or whether it will be Instagram live. So join in with me. I'll post all the details on my Instagram handle, which is Shreyas_Vedantu. Okay, so I'll be posting it up on Shreyas_Vedantu, all the details of it. Let's join and let's see how you guys are celebrating. I'm going to be with my friends and family out there. in a farmhouse. So if you want to check me out, definitely join my celebrations for just 5 minutes. I know you will be also celebrating with your friends and family. So I'm not going to take much of your time, just for 5-10 minutes. I'm just going to say hello to everyone and probably join in. All right, Bhargav, I'll be posting it probably on the Telegram group. Now, here's the next thing. Can we convert everything into a spring mass system? And the answer is yes. Imagine if there are multiple springs and there is a block attached. I can reduce those 2 springs or 3 springs or 4 springs into one single spring. And the equivalent spring constant in series is ulta, it's opposite of resistors. It's just like capacitors, by the way. If you are in 12th standard, you know what I'm talking about. When things are in series, what happens for resistors? You add. But when resistors are in parallel, you add the reciprocals. So same thing happens in springs. This is what happens in the springs. You will notice each spring has the same force. Understand, it is the same wire. My bad. Each spring is the same wire. So the tension is itself the spring force, which is also that pulling force. So tension, spring force will be same in all of them, but what will be different will be their extensions. Their extensions won't be the same. Remember that. So each spring will be extending by different amounts depending on how much is their spring constant. Okay, so remember this formula. When 2 springs are in series, this is the formula that you're going to use. So obviously what's coming up next? You know that it's going to be parallel, guys. So when 2 springs are in parallel, you can convert those 2 springs into one spring. Now what happens is, because you are pulling both these springs together, you will see both springs will have same X, but this force will get divided as F1 and F2 in both these springs. And they might not be equal because the spring constants might be different. So the force gets divided, and in fact F will be equal to F1 plus F2. That's what will happen. And this equivalent spring constant will be K1 plus K2. So for parallel, it is series formula for resistance, and for series it is the parallel formula for resistance. That's what you should keep in mind. Definitely we can. I'll do that. All right. So let's solve some problems. Why not? Let's solve some problems. Find a time period for oscillations in the following. I'll be like, sir, where are the diagrams? Don't worry, I'm going to draw it. All right. So let's see what the diagrams are. Very interesting questions. Let's see how many of you can do this. Come on. There we go. Okay. And you have a block here. K, K, 2K, 2K, and K. So find the time period in this case. That's your first question, guys. Come on. Then the next question I'm going to draw over here. Hold on. M, K, K, and K. Again, find the time period over here. And then and you have 3K over here. Again, find the time period. Come on, let's try to solve all these questions. Very interesting questions out here. Okay, anybody who wants to give the answer for the first part? Okay, so what you need to do, guys? All right, Asmi is here. Welcome, Asmi. Our 10th standard fan and mascot. All right, who is eagerly waiting for the jacket. All right, so let's see, guys. So first, convert both these two Ks into one simple spring constant. They are in parallel. When they are in parallel, just add them. Just add them. Yes, just add them. Remember that. So it will be 2K plus 2K, which is 4K. Now this 4K and this K are in series. So use the parallel formula. So just use this, guys. So this was 4K, right? So 4K into K divided by 4K plus K. So it will become basically 4K by 5. This is the spring constant. So naturally the time period will be 2 pi under root m by equivalent K, which is 4K by 5. And if you want, you can cancel that 2 over there, and you can make it as pi root 5m by k to make it look a little bit neater. That's how it is. Is that okay? Everyone understood this first part? Everybody understanding this first part? All right, great. So let's go to the next part. Here, all of them are in series. So use the parallel formula. So guys, 1 by k plus 1 by k plus 1 by k 3 times is 1 by k equivalent. So k equivalent will be k by 3. Now just use the formula 2 pi under root m by k equivalent. What is k equivalent? K by 3. So 3 goes on the top. So that's the answer. Is that correct? Yes, very good. Now comes the best problem. I know what you guys are thinking. These two are in series. Guys, you guys are wrong. Yes, that's not the correct answer. Think about it. This is not in series. I'll tell you why. Understand, if this block moves, okay, there was that spring over there, that block, and another spring over here. If this block moves slightly over here, what is the direction of the force by this spring? It will be here, it will pull it, and this spring will push it over there because this is getting compressed. How will this diagram be different from this diagram when both the springs are on the same side? Think about it. When this block has moved towards your right side, think about it. This spring will also pull, this spring will also pull. Don't you see the forces are exactly the same way? Aren't you seeing that this diagram is the same as this diagram force-wise? Instead of pulling, it is pushing. That's the only difference. So guys, actually the springs are in parallel. So understand that the K equivalent will be K plus 3K since they are in parallel. That means it is 4K. So therefore, time period will be 2 pi under root m by 4K. So you can simplify it and write it as pi root m by k. That's the answer. Interesting. Interesting. Very good. Thank you, Asmi. Thank you so much. Perfecto. Excellent. Let's get going. Now, let me tell you one more thing. See guys, whenever a spring mass system oscillates in the vertical direction, okay, in the vertical direction, there is one constant force which will act on it. Who is that constant force which will act on it? Shreya, this is very important chapter, as important as rotation. Who is that constant force will act on it? mg. Correct. Now you might be wondering, what will mg do, sir? Please tell me, what will mg do? Will mg do anything for this? Well, we are going to talk about this. And is it going to affect the time period? Is it going to do something else? We are going to talk about this now. See guys, understand that the equilibrium position, this one out here, this one is not the natural length of the spring. Please understand that. The natural length probably of that spring could be somewhere here. Maybe it is just this much. But because you have pulled it because of this block, understand the equilibrium position is going to be somewhere else. Yes, it's going to expand, and that's what we are going to talk about. Okay, once again, I'll use this diagram only. Okay, so imagine this is the natural length. So this is when it is at natural position. If I tell you what will be that length, okay, let's say d, for which this block stays in equilibrium, that position where it stays at rest. Example, that is very simple. At equilibrium position, okay, at equilibrium position, understand the upward force will be equal to the downward force. Downward force is mg, upward force is kx. What is x? the spring has extended by d, so it will be kd, and that's how it is at rest. Therefore I can say kd is equal to mg, therefore d is equal to mg by k. That is that distance at which it stays in equilibrium. It will stay there as it is. But now if you disturb it, if you give it some impulse, if you move it, it will start oscillating like this. Understand the amplitude depends on how much ever disturbance you give. So you can give it a small disturbance, it will oscillate only a little bit. If you give it more disturbance, it will oscillate even more. Now think about it. If you move it by some distance x, what will be the new force acting on this block? I want to find what will be the new force acting on this block if I move it by some x. Remember, this force will be just k into the total extension, correct? The force will be k into total extension, which is d plus x. I hope this is clear. Now, at that instant when it has been moving and some random x position is chosen, when the force is k d plus x at that point, if I draw the free body diagram of that mass, the forces acting will be that F and obviously mg. Now just think about it. If I ask you, what is the net force acting on it? What is the net force acting on it? Well, if I take this direction as positive, it will be mg plus, mg is positive and this force is negative, so minus F. This will become mg minus this value of F, which is k into d plus x. Now this will become mg minus kd plus, minus kx. But hold on, what is mg and kd? Mg and kd are equal. Did you see that? Mg and kd are equal. So what will it become? Minus kx. What is this telling you? What is this telling you? This is telling you that the net force is still as if there is one spring. Forget that gravity. The net force is just as if there is that spring, and that means it's still going to oscillate as usual. That means the time period should be just 2 pi under root m by k. So time period does not change. Time period does not change. Yes, correct guys. Time period won't change. What will change is the equilibrium position. The equilibrium position will shift. Instead of being at natural length, it will shift by a value of mg by k. That's all you need to know. Yes. And it will be a constant. Yes, it will be a constant. It is independent of g. Remember this. It is independent of g. Very important. So constant force does not change the time period. It could be mg, it could be f naught, it could be some other thing. What does it change? It shifts. What does it shift? The mean position. By how much? The constant force divided by k. Alright. Now, today I had planned some more things, but it doesn't look like amplitude depends, Aishwarya, completely on you. Amplitude is not dependent on k, m or anything else. It depends on how much did the external force disturb it. I don't want to complete too many things. I want you to first grasp all these things today. I will probably realign my further lectures and we will meet again tomorrow. Alright, so I had planned few things. I'm just going to do all these things later on. Don't worry. And guys, remember, Ekalavya batch for all the 12th standard students is starting very soon. The entrance test for it will be happening. I'll be giving the dates. Remember, Ekalavya batch is a special batch for JEE Advanced with master teachers like AP sir, Pulkit sir will be conducting special sessions, and I will be also teaching. Shimon sir will also be there. I have in fact taught, even Shimon sir has taught last year as well. And there are going to be lots of questions, assignments, part and full syllabus test series, discussions, and also counseling after you clear your JEE Advanced examination. So these are the toppers which we have produced last year, alright, in the Ekalavya batch where we have taught. All right, there are 550 selections, and look at the change, guys, before joining Ekalavya and after joining Ekalavya. You can check their mains rank. Their mains rank was somewhere here, and how their advanced rank has drastically improved. You can see all the details. It is there in the PDF. So guys, remember, anybody who is eligible for JEE Advanced 2021 is also eligible for the Ekalavya batch. It is free of cost till the end, no charges. So you have to clear the entrance test for that. So the first entrance is going to be on January 3rd, 2021, next on 7th, and next on 10th. So these are the only entry points. There is no other entry point for this batch. Thank you very much, guys, and do check out the Telegram group for more details. We'll be posting many details and how to fill up the forms, etc. on the Telegram group. So do join it. And if you have loved today's session, do not forget to hit the subscribe and hit the like button out there. All right. So guys, see you. Bye bye. Have a great time. Satvik, maybe when you clear JEE, definitely I'll meet you. All right. So that's the only way, at least now in this difficult times of Corona. Okay. Bye bye, guys. Have fun and keep learning. See you again tomorrow. Bye bye.